Okay, so now with the question 3, it's Circles Theorem. Now, if you've not done Circles Theorem yet, there is a link above right now. You can click on it and look at the Circles Theorem I've done on my page already. But if you have idea about Circles Theorem, let's go straight to it. But remember to subscribe to the channel and also click the notification icon. Now, this is the question. It says that in the diagram, the diagram is a circle. That is MNPR, and O is the center. The reflex at O is 204 degrees, and angle MNO is 52 degrees. Find the value of M. So we are finding this angle M here. Now with this question, we have two ways of solving it. So I'll urge you to stay with me so that we look at all the two ways of solving this particular question. We will come and get the same answer. Now, so method 1. So method 1. Now the method 1 is that we will extend this line over here to the center. We will extend this line here to the center so that MON becomes a triangle. And that triangle is an isosceles triangle because from here, for the circumference to the center is the radius, and also from here to here is a radius. And because all the radius of the same circle will be the same, then it means that this is an isosceles triangle, of which this angle here will be 52. So in writing form, triangle MON is an isosceles triangle. It's an isosceles triangle. Therefore, angle MNO is also equal to 52 degrees. Why is that? If I turn the diagram like this, you see that this one becomes the base of the triangle, and this one becomes the sides of the triangle. And isosceles triangle says that the bases are the same. So if the bases are the same, if this side is 52, this side is also 52. Please, not all this side, but half of the angle here, or part of the angle here will be what? 52. Good. Now, after that, this angle here, from here up to here, not the full angle. From here up to here, we have to find it and deduct this from the 204 so that we will know this side, not the full 204. So what we will do is consider triangle MNO. So triangle MNO looks like this, with here as M, N, and O. And we have here to be 52, and we also have here to be 52. And we are looking for this angle. Yeah, we are looking for this angle. That's the O, this side of the angle. Sorry, so we are looking for this side is 52, and we are looking for this angle. So what we'll do is we'll add this to this. Let's put a variable here. Let's say x. This to this to this. Then equate it to 180 because interior angles of a triangle sum up to 180. So it will be triangle OMN plus angle MNO plus angle MON equal to 180. But this angle is 52 plus this angle is also 52. But this angle we replace it by x equal to 180. So we will get 104 plus x equals 180. Then we are going to get x equals 180 minus 104. So our x will be equal to 180 minus 104. And from the calculator, we are getting 76. So 76 degrees. So that 76 degrees, when it comes to this diagram, that is this side. From this side, this line here, up to this side, is 76 degrees. Now, from the question, we're given that the full angle here, from here to here is 204. And we now know that from here to here is 76. So we can find from here to here by subtracting 76 from 204. So we'll continue by saying that if angle MON equal to 76, then angle NOP will be equal to 204 minus 76. Then angle NOP will be equal to, so 204 minus 76, give me 128. 128. So the angle here from this side to this side is also 128. Now we want to find this angle. That's what we are looking for. That's what the question is asking. But we can't find this without finding this, because we divide it into two. So because this one, when I turn it like this becomes the base. So this side can be y. And because an isosceles, the bases are equal. So here too can be what? Y. So we can have, if we consider triangle ONP, then angle NOP plus angle OPN plus angle PNO is equal to 180 degrees. Then NOP is 128 plus this one we don't know, we used y. This one we use y equals 180 degrees. So this one gives you 2y being equal to 180 minus 128. So 2y will be equal to 180 minus 128. You give us 52 degrees. We are not done. We are finding y. So we divide here by 2 and divide here by 2. So we're going to get y is equal to 26 degrees. So it means that this side we used y, but in the question was m. So therefore, y equals m. Hence, m equal to 26 degrees. So we have find this m here, but we use it for, that's why I said therefore y equals m. So m is 26 degrees. Now we have find the angle m. Or another way we can do this work also is that we will not divide this side into 2. We will not divide this side into 2, but we'll get the same m as 26. So let's look at the method 2. So method 2. Now, it's so simple that this is the center as O. So we know that angle at a point sum up to 360. So we'll use this to find this. So 204 plus angle MOP, it's equal to 360. So 204 plus angle MOP is equal to 360. Now we are going to get MOP, that's the angle, equal to 360 minus 204. So we're going to get angle MOP being equal to 360 minus 204. And that is 156. That is 156. So the angle here is 156. Now, from the properties of Pythagoras theorem, it says that the angle, 2 of the angle here is equal to this angle. So if we know this to be 158, we can get this angle through this one. So let's come back. So we know that 2 of angle MNP is equal to angle MOP. But we know MOP. We know MOP, but angle MOP is equal to 156. So we are going to get 2MNP is equal to 156. You divide here by 2 and I divide here by 2. So I'm going to get angle MNP being equal to 156 divided by 2. So 156 divided by 2 gives me 78. So that's the angle up there. Angle MNP is equal to 78 degrees. Now, 78 degrees. Now, coming back here, it means that you said this angle is 78 degrees. Now, we can consider this. We have a quadrilateral in this question. This, and that. It's a four-sided figure. 1, 2, 3, 4. 1, 2, 3, 4. It's four-sided figure. So we know here to be 78. We know here to be 152. We know here to be 204. So if we add, you see, interior angles of a quadrilateral sum up to 360. So we know here 78, 152, and 204. If we add it to this and we equate it to 360, we'll get the M automatically. So let's go that. So consider quadrilateral MNPO. So we are going to get 52 plus 204 plus 78 plus M equals 360. So we will add everything. So 52 plus 204 plus 78 plus M. M we don't know, so we will just leave it. It's equal to 334. So we are getting 334 plus M equal to 360. So we are finding M. So to be M being equal to 360 minus 334. Then we get M to be equal to what? 26 degrees, as we had over here. So this method is short, but we have to know that this shape here is a quadrilateral. Then use the rules of quadrilateral to solve it. Or we use the first method as we did. You consider some triangles, then you solve them nicely. Are we good? So that is question 3A. Question 3A as far as the Wassce for 2021 is concerned. So let's look at the B. Now it says that. Now the B says that. The B says that a ladder leans against. A ladder of length 6.5 meters leans against a vertical wall. If the top of the ladder is 3.6 meters from the foot of the wall, calculate to correct to 2 decimal places the distance from the wall to the foot of the ladder. Now, as far as we see a ladder leans against a wall, we are talking about Pythagoras Theorem. It's Pythagoras Theorem. So let's draw our right angle triangle, because by all means we'll get a right angle triangle. And we are saying that a ladder is leaning against a wall, a ladder of length 6.5. So if this is the wall, this is the wall. This is the wall, and a ladder is leaning on, and the ladder is leaning on it. The ladder will be this. So this is the ladder L. So this is the 6.5. That's the ladder M. And it says that the top of the ladder is 3.6 from the foot of the wall, or to the foot of the wall. So from here, that's the top of the ladder, to the foot of the wall is what? 3.6. So that's the length of the wall. That's 3.6 meters. 3.6 meters. And it says that calculate to 2 decimal places the distance from the wall to the foot of the ladder. So we are finding here, so we don't know, we put X over here. Now what does the law of Pythagoras says? It says that the square and addition of the hypotenuse and adjacent is equal to the square of the hypotenuse. In writing terms, it says h square, that's the hypotenuse square, is equal to opposite square plus adjacent square. So the hypotenuse is 6.5. So 6.5 being equal to, now because we don't have any angle anywhere, we can choose any to be opposite and choose any to be adjacent. So let's choose this as opposite and this as adjacent. So we will have 3.6 square plus x squared. Now our calculator will come in here. So 6.5 square gives us 42.25 being equal to 3.6 square also gives us 12.96 plus x square. Now we are looking for x square, so we'll let x square stand alone. So we move 12.96 to the side. So we'll get 2.25 minus 12.96 being equal to x square. So let's subtract the two. So 2.25 minus 12.96 will give me 29.29 being equal to x square. So now we are looking for x and not x square. So what do? We square root both sides. So we square root here, then we square root here. So the x will take care of, the square will take care of the square root. Then we're going to get s is equal to the square root of 29.29. So we use our calculator, 29.29. Then we are going to get x being equal to 5.4120. 5.4120. But the question said something. The question said correct to 2 decimal places. So we can't leave our answer like this. We have to correct it to 2 decimal places. So after the 5, after the point, we have this and that. If this was more than 5, we will have rounded to make this one what? 4.2. Because it is less than 5, we will leave it as 4.1. So we have s equal to 5.41 meters. That is the length of the foot of the ladder to the foot of the wall. Are we good? That is the solution. So that is it for question 3 as well for 2021 general maths or core maths question.